Hello all. So in today's class again we'll continue the distribution problem. So we were seeing the number of ways of distributing our distinct objects to n boxes. So we will see the next case. So next is, assume that each box can hold any number of objects and the orderings of the objects in each box count. So here each box can hold any number of objects and the orderings of the object in the box count. So when you change the order, so that gives a different arrangement here. So suppose we have the objects, so let A1, A2, etc. An be the n distinct, be the R objects you are having. So you are having R distinct objects, and now we are having n distinct boxes also. So let A1, A2, etc. AR be R distinct objects, and there are n distinct boxes. Then the first object A1, so it can go to any of the boxes. So then A1 can be placed in any of the n boxes. So therefore there are n ways to do this. So there are n boxes, so it can go to any of the boxes. There are object arrange it, so there are n ways to do this. And now let us see what happens to the arrangement of the second object. Okay, so let us take it as box 1, box 2, box 3, so on. Box, you have n minus 1, then you have box n. Suppose my object A1 goes here, and now the second, let us place the second object. So the second object A2 can be placed here A2 can be placed in box 1, box 3, so on box n. ഇനി നമുക്ക് box 2 place ചെയ്യാം. box 2 place ചെയ്യുമ്പോൾ you can place it either on the left side of A1 or on the right side of A1, because since ordering matters, it's different when you place it on the left side and right side. So the second object can be placed in any of the n minus 1 boxes not containing A1, and it can also be placed in in the right or left of A2, right or left of A1. So there are total, so you have n minus 1 plus you can either put it on the right side or left side. So there are n plus 1 ways to do this. And now let us look at what happens in the case of A3. So let me put say my A2 is here, and now if A2 is here, so I can put the object A3 in this n minus 2 boxes. n minus 2 il place cheyyam. Ini n minus 2 il allengil object 1 or 2 o irikkunna box aanengil, so 1 inde left and right place cheyyam. Adupole 2 inde left and right place cheyyam. So there will be 4 such ways. So n minus 2 plus 4, so that will be equal to n plus 2. So this is the number of ways to place the third object. So similarly, third object can be placed in n plus 2 ways, and the rth object, so that can be placed in n plus r minus 1 ways. So therefore the number of arrangements is given by, so by multiplication rule, so that will be n into n plus 1 into n plus 2, so on n plus r minus 1. So that is the number of the required arrangements. Now let us move on to the second type of distribution problems. So the second type of distribution problems is, so that is a number of ways of distributing r identical objects into n distinct boxes. So that is distributing r identical objects to n distinct boxes. So let us see the first type of problem when you have r identical objects and n distinct boxes. So the first type of problem is, so assume that each box can hold at most one object, and now for this to happen, so you must have r less than or equal to n. So the number of boxes must be greater than or equal to the number of objects. Then only you can have each box containing at most one object. And when here you have r identical objects and n distinct boxes, ini namakku ariyendadu the number of distributions such that each box can hold at most one object. So there are total r objects. Appo r object ne നമ്മൾ ഓരോ ബോക്സിലായിട്ട് വേണം പ്ലേസ് ചെയ്യാൻ. അപ്പോൾ out of the total n distinct boxes, we need to select just r boxes. So that can be done in NCR ways. So therefore here the number of distributions will be NCR. So the problem is same as selecting those r boxes out of the total n boxes, which can be done in NCR ways. So here there is a 1-1 correspondence. between the ways of distributing ways of distribution and ways of selecting R boxes from the given n distinct boxes. So this can be done in NCR ways. So that is the required number of ways. Now the next case is, so assume that each box can hold any number of objects. Now, when each box can contain any number of objects, so here the problem is identical to the number of, so this will be equal to the number of R combinations of n different objects with any number of repetitions allowed. So this is the number of R combinations of n objects with n repetitions allowed. So നമുക്ക് R objects ഉണ്ട്. So R objects place ചെയ്യാൻ നമുക്ക് boxes choose ചെയ്യണം. N boxes ഉണ്ട്. So those n objects can be chosen with repetitions. So this is equal to the combination with repetition. So that will be equal to H n R. So that is n plus R minus 1 C R. So that is the number of ways. Now the third case is assume that each box holds at least one object, that is R greater than or equal to n. So that is the case when no box is empty. So in this case no box must be empty and R is greater than or equal to n. അപ്പോൾ നമ്മൾ ചെയ്യുന്നതാണ്, നമ്മൾ ആദ്യം എല്ലാ ബോക്സിലും ഓരോ ഒബ്ജക്റ്റ് വെച്ച് ഫില്ല് ചെയ്യും, എന്നിട്ട് ബാക്കിയുള്ള ഒബ്ജക്ട്സിനെ ആയിരിക്കും നമ്മൾ ഡിസ്ട്രിബ്യൂട്ട് ചെയ്യുക. സോ we first put one object to each box. So this can be done in one way only. This can be done only in one way കാരണം നമ്മുടെ objects identical ആണ്, and then we distribute the remaining R minus n objects, and this distribution can be done in with repetitions. So therefore the number of distributions will be equal to, so that is the number of R minus n combinations of n objects with repetition. So that will be equal to R minus n plus n minus 1 CR minus 1 R minus n. So that will be equal to R minus 1 C R minus n. So you need to find the number of R minus n combinations. So ബാക്കി R minus n objects n places arrange ചെയ്യണം with repetition allowed. So that can be done in these many ways.